Okay, so today's topic is transformation of parent functions. We are continuing actually the previous lecture. We were doing transformation of parent functions. So we'll have to complete this. Hopefully, we'll complete this by today. So first of all, I have to tell you one thing, that whenever you are doing some operation with y, like suppose this is a function, say f of x equals, say x x plus 1, or you say 2x plus 1. Okay, is this a linear function? Okay, now basically if I say I'm doing some operation with y, I'm multiplying or I'm adding something with y, this basic, as you know, that function f of x is replaced by y, which is both are the same things. So you can write y equals 2x plus 1. Now if I say I'm doing something with y, suppose if I am multiplying some number, some constant with y, say 2. So what I will do, I'll multiply, if I multiply 2 with y here, I'll have to multiply the 2 with the whole equation on the other side as well. So I got 2 times 2x plus 1. Okay, so this is this would be in case if I doing operation with y. Okay, now let's say I am not doing with y, I am doing something with x. Say if I am adding something or multiplying something with y, say what would I do? I'll do operation on x, only x, and not do like the whole function. If I do with y, I'll have to do the operation thing with the whole function. But in case of x, I'll just write here, like suppose if I'm multiplying 2 with x, so I'll write 2x here. So like x would be replaced with 2x. See, x value would be replaced with 2x in the function. So 2 here, x would be replaced with 2x. Okay, plus 1. So we got 2 times 2 is 4x and then plus 1. Okay, this would be the answer. Okay, so they both are different in like if we are multiplying 2 with a y, we will be getting 4x plus 2. But if we are multiplying 2 with x, we'll get 4x plus 1. Now just start today's lecture. Now we talk about the graph. Now it's about moving the graph to left or right. Okay, so what we can do here, we can move it left or right by adding a constant to the x value. Remember, to the x value. So that's the difference. I tell you what, when we do some operation with x value or y value, what's the difference? I already tell you. So here, if you want to move graph left or right, you have to do the operation with x value. You'll have to add something, add a constant to the x value. Yeah, any constant. You can take any positive or negative constant. Now this is a figure. In this picture you can see initially this was a graph which was a graph of a quadratic function. The graph is like, let's say f of x equal x square. This is the graph for this function. So it's a parent function, basic function, and this is the graph for that function. Okay, now what we do, we add a constant in it, we add c in it. So what is happening, the graph is shifting left side, translating left side, so it's moving here. Okay, so this is the new graph which is for x plus c. Now one thing very important, if you add c, moves the function left right, the negative direction. It's in the negative direction. It's not the positive direction. So you can say that this is negative x. This is positive x on the right side. Left side, this is negative x. So when you add a constant, the graph move to the negative direction. So I'll write it, if the constant c is greater than 0, sorry. So graph would move left. Okay, if you are adding a constant which is greater than 0, graph moves left. Okay, same upon if the constant is less than 0, which means negative value, any negative number, graph moves right. Yes, the greater than 0 mean positive numbers. All the positive number. If you add a positive number in the x value, graph moves left. If you add a negative number in the x value, the graph moves right. Okay. Now this is what all about moving the graph left to right. Okay. Now this is about moving left and right. And the next thing we have to learn is how to move the graph up or down. Okay. Yeah, actually we done this to move the graph up or down. We actually already done this in the previous lecture. The lecture we taken last time. So we have the next thing here, which is about stretching and compressing. How to stretch or compress the graph. So that's very simple as well. So we can stretch or compress it in the, right now we are doing in the y direction. Okay, it's in the, we'll do in the x direction as well later on. In the y direction, by multiplying So how to stretch or compress? By multiplying the whole, not say whole number, whole function. So if you want to stretch or compress in the y direction, you have, like in the graph, you have to multiply the whole function by a constant. Now let me show you the diagram. Actually just make it this way. Yeah, say initial graph is this one. Yeah, stretching. Yes. Now see what happens. The graphs look like that. Okay, so what happens here, the graph is going like that. Graph is compressed here. Okay, this was the initial position, this was the initial position, right? And the graph compresses and it becomes like that. Okay, so we have actually multiply something with the whole function. Say if this is the function g of x, we multiply with it, like it becomes 3x. Okay, so we multiply something, actually say 0.3. okay, so this happens in the result. Now see, there is an important point here. When the constant, let me say is, just give it a constant c. When the constant would be greater than 1, right, then it would stretch. Okay, greater than 1 means it can be 1, 2, 3. Greater than 1, it would be stretch. Okay, and when the constant would be greater than 0 and less than 1, which can be a decimal, 0.1, 0.2, 0.3, then it would compress. Okay, as you know the difference between stretch and compress. Okay, stretch means it become more more smaller, we'll say. Compress means it's become bigger. Okay, right now, no, hold on, it would stretch it to, yes, see here, in this graph it is compressing. Okay, because what happens if I put the value of constant here, it can be like that, 0.4x, right? Yes, it can be any value. Right now we just understanding generally. We'll do the examples. Yeah, we'll do the examples in later on. So right now this example, it can be a decimal. That's why it is compressing. If it is a number greater than 1, it can be 2, 3, 4. Then it would be stretches like that. It becomes like that. Okay, it would becomes stretched, right? If the number is greater than 1. But if it is less than 1, it would compress like this way. It becomes more bigger. Okay. Yes. Okay. Now the next thing, we have done this, like we have stretched or compressed, we are talking about in the y direction. We can also do it in the x direction as well. Okay, by multiplying, like right now we are multiplying any constant with the whole function. Like in case if you want to do it in the x direction, right, you have to multiply with only with x value. Okay, so let me write this for you. By multiplying x. Okay, and remember, wherever x comes, okay, wherever x comes, you have to multiply by a constant, any constant you can. Yeah, it's probably the first chapter of your book, about parent functions, transformation of parent functions. Yeah, Nelson functions 11. Yes. So right now we'll see the diagram and I'll tell you how it looks, what happens. Now this is the diagram here. You can see here that this way, like if you're multiplying something with x, what happens? So we are not multiplying, see here, if you are multiplying 2 here, you are only multiplying 2 with x value, not with the whole function. Previously we were multiplying with the whole function, and that's why there was a change in y direction. Now it's happening in the x direction. Okay, so So see here, when you multiply 2 here, this was the original function, right? And it goes like that, okay, right? Right? Now again, I'll write the thing is, like, if the constant is greater than 1, like the graph would compress. Okay, previously if the constant was greater than 1, it was stretching, right? Remember, if we were doing in the y direction, it was stretching. Now if the constant is greater than 1, it's compressed. Okay, and if the constant is greater than 0 and less than 1, then it would stretch. So as you see, unlike for y direction, like previous graph we were working on, bigger values cause more compression. Okay, see here, bigger values here causing compression, and previously if you see, bigger values, there was stretchness here. See, c is greater than 1, the function was stretching. Okay, now in the x direction you have bigger values, the function would compress. Okay, when you do some change with the x thing, when you multiply something with x value. Now you got the difference between when you do some operation with y direction, you will multiply the whole with the whole function. Like in case if you are doing with the y, then you have to multiply 2 here, right? But if you are doing with x, you have to multiply inside. Whatever x would be changed, like you are multiplying 2 with x, so you'll go here wherever the x would. Yes, obviously, yeah, it is changing y value as well. That's why. But you have to do the operation with x, right? You can see the differences. So say I'm multiplying with the y, same number 2. So what would happen? I'll got this g equals 2x square, right? But if I'm multiplying it with x, I'll got, instead of x, I'll do 2x, and I'll got 2, and x I'll write. Sorry, the original function, the parent function is x square. So instead of this, we'll write 2x here. So if you take square of 2, you got 4, and then take square of x, you got x square. So you're getting 4x square. See, two different things. Okay, so that's the difference. That is why you are getting change in result as well. In this here, you're getting compression, right? In the same value, if you're taking greater than 1, constant greater than 1, and here you're getting stretchness. It's being stretched in the upper one. Now we can flip it as well. Like we can flip it upside down, right? We can, like, if you have graph like that, say this one. This is a graph. Say you have a graph of quadratic function, which is like that. You can also flip it like that. Okay, you can move this graph from here to here position, this position to this position, right? How can you do that? By multiplying some negative number. A -1 can do that for you. Okay, just multiply the whole function with -1, the graph would get flipped. Okay, it's called as reflection. It's also called as reflection. Okay, it's not stretchness. Okay, it's called as reflection. Okay, no, it's kind of two different concepts, reflection and stretchness. Reflection, like you have learned in physics as well, it's get reflected. The whole function, the whole graph is get reflected on the other side. Yeah, it can stretch as well. It can stretch as well and reflect. Yeah, you already learned how can you do stretchness. Like if you are multiplying it with 2, what stretchness would be applied? But if there is a negative sign, same stretchness applied, and after negative sign, flip it on the other side of the graph. It would reflect it. Okay? Stretchness would also apply on that position, the same way you learn. And the reflection would happen. What happened with reflection with the negative number? The graph would reflect it on the other side. Okay? It's up to you. You can do both in one step, or just for your yes, both. But only -1, there would be no stretchness. Okay, because you have to take greater number than 2, or lesser number than 1. Okay, lesser number. Yeah. So one can just keep the same function, and just reflection would occur, no stretchness. Okay, -1. So say you can have a, say g of x is, this function is x square, right? And what happened for this function? You got -x square. This is for -x square, this function. Okay, just a -1. -1 is multiplying, and you get a function reflected, same function reflected on the other side. So it's also called as reflection on the you can say it's reflection on the x-axis. It's reflection about the x-axis. Okay. And the other thing, the last thing we're gonna learn is to how to flip the graph on left or right side. Okay. I can't give you the example using the same quadratic function, because quadratic function can't flip on the left and right side. It would stay the same. But I'll take a square root function. Say here. Let's take a square root function. First, let me tell you, this is a square root function. G of x equals square root of x. Okay. Now, how can I flip it? I'll multiplying. Previously, what I was doing, Chavez, I was multiplying negative number with the whole function. This time, I'll multiply -1, as you say, -1 with the x value. Yes, just to change the x. Okay. So what would happen? I'll got this, instead of x, I'll substitute -x instead of x. Okay. So I got negative square root of x. Okay. So what happens in this case? Say the graph of g of square root of x looks like as you already studied, the graph of square root function looks like that. Okay. But when you do negative square root of x, okay, it would flip it on the other side. Okay, it would go like that. Yes, it will go like that. So it changes occur from here to here. You see that. So that's the consequences. If you do something, previously we learned, if we multiply a negative number with the whole function, which means with the y value, the graph flipped upside down. But if you multiply negative number with the x value, the graph flips right to left. Okay. So this is also called as reflection about the y-axis, as the y-axis is involved here. You can see that previously there was x-axis that was involved. Yeah, you can compress it, but you have to multiply the number. You can say, yeah, it can bigger. It becomes bigger. Yes. Yes, but you have to multiply number bigger than 1. Okay. In case of compression, as you already learned. In case of x value, if you are multiplying it with x, you have to multiply a number which is greater than 0, less than 1. Then the compression would occur. Okay. This is in case of y value. If you're doing with the y value, then you can have to take a number greater than 1. Then it would be compression occurring. So that's pretty much end of the transformation of parent function thingy, like the basic concept. We'll be working on the examples later on. So right now I'll just explain you in the summary, just giving you a quick look at that. You see the summary here, which would be just sums up the whole concept, the whole lecture. See here, y equals f of x plus c, right? What we are doing here, Chavez, we are adding something in c, constant, into the whole function. We are adding a constant in the whole function. What happens if the c is greater than 0? Graphs move up. If c is less than 0, graph moves down. Okay. Now what happens when you add a constant in x value like that? Then if c is greater than 0, graph moves left, which is just opposite to this one. You can see that. Okay, and when c is less than 0, a negative number, moves it right. Okay, same upon if you multiply a constant with a whole function and c is greater than 1, stretches it in the y direction. C is greater than 0 and less than 1, which means a decimal number, it compresses, as we already learned. Then if you multiply a constant with the x value, c is greater than 1, compresses it in the x direction. Okay, and c is a decimal number, it stretches it. And then I already learned, if you multiplying a negative number with the function, the whole function, it reflects it about the x-axis. When you do it with the y value, sorry, the x value, when you multiply a negative number with the x value, it reflects it about the y-axis. So that is what all about transformation of parent functions. We will be discussing the examples and the questions related to that, so for the practice, and we would understand the lecture better if we do some examples and questions as well.